Hey pre-calculus, so next one, double angle identities. We don't do half angle identities in this course, although you're welcome to look at them if you like. They're very useful. But we're going to focus on the double angle identities. So, just like with the sum and difference, we're going to have a motivating question. Is cosine of 90 degrees the same as 2 times cosine of 45 degrees? That is, 90 degrees is 2 times 45. Can you basically distribute, or can you change the order of multiplication and cosine? Well, we know cosine of 90 degrees is supposed to be 0. And cosine of 45 degrees is the square root of 2 over 2. So 2 times cosine of 45 degrees would be square root of 2. Those are not the same. If you put it in your calculator, 2 times cosine of 45 degrees should give you like 1.414. Not the same. So, if you are taking cosine of twice the angle, you can't just double the cosine. You need to use a formula. Once again, I'm going to give them to you. This one, the formula, the proof is actually very simple. It comes from the sum identities that we just did last class. And that is, if you want to do sine of theta plus theta, that is 2 theta, you go ahead and plug it into the formula for the sine of the sum of two angles. So sine theta cosine theta plus cosine theta sine theta. And you get 2 sine theta cosine theta. So that's our formula. Same for cosine 2 theta, we'll do cosine of theta plus theta, cosine theta minus sine theta sine theta. That comes out to be cosine squared minus sine squared. That'll be our formula for cosine of 2 theta. Now, because cosine squared can be replaced with 1 minus sine squared, and sine squared can be replaced with 1 minus cosine squared by the Pythagorean identity, there are actually 3 different possible formulas you can use for cosine of 2 theta, and you use whatever's easiest for you. It doesn't matter at all, they all equal the same thing. Here is the formula for tangent of 2 theta. You don't need to learn it, and you don't need to use it, but I'm giving it to you just for fun. Alright, so if sine of theta is 3/4, and theta is in the first quadrant, that means, that's important because, well, alright, let me read it and I'll tell you why it's important. And theta has its terminal side in the first quadrant. Find the exact value of each function. The reason it matters where the terminal side is the formula for sine 2 theta involves cosine of theta. And if theta were in the second quadrant, sine would be positive, but cosine would be negative, and that would make a difference. But here they're telling us that they're both in the first quadrant, or that it's in the first quadrant, so sine and cosine will both be negative. Will both be positive. Sorry. So sine 2 theta, we're going to use the formula, which is 2 sine theta cosine theta. But we don't know cosine theta yet. So just like we did before, we're going to draw a triangle. We'll label our opposite side 3 and our hypotenuse 4. This is not a 3, 4, 5. Don't get tricked. We need to do basically a squared plus b squared equals c squared. So a squared is 16 minus 9, or 7. A is square root of 7. So that means cosine of theta is going to be square root of 7 over 4. So now we can plug in 2 times sine of theta. Sine of theta is 3/4. Times cosine of theta, which is the square root of 7 over 4. That gives us 6 times the square root of 7 over 16. Don't forget to multiply the bottom. And that can actually reduce into 3 square root 7 over 8. That's sine of 2 theta. For cosine 2 theta, we're going to use the same values we just found. So cosine of 2 theta equals, we could use any of these formulas. I'll go ahead and use the first one. Cosine squared theta minus sine squared theta. So that will be cosine theta is square root 7 over 4. So square root 7 over 4 squared minus, and sine theta is 3/4. So 3/4 squared. Please don't forget you have to square them. This won't work otherwise. 7 squared is 7, or sorry, square root 7 squared is 7. 4 squared is 16. 3 squared is 9. 4 squared is 16. And we get Wait, no, that's right, sorry. Negative 2/16, which simplifies to negative 1/8. Just so you know, let's try another one, just to verify. Let's try 2 cosine squared theta minus 1. So the nice thing about cosine 2 theta is if you only have cosine or sine, you actually don't need to find the other one because you can just use the formula that only uses 1. So this will be 2 times square root of 7 over 4 squared minus 1. That's 2 times, and the square root of 7, square root of 7 squared is 7. 4 squared is 16. That'll be 14 over 16 minus, I'll replace my 1 with 16 over 16, negative 2/16, negative 1/8. See? Same thing. The equations are identical. Sine 4 theta. We don't have a formula for that, but we don't need to. This is sine of 2 times 2 theta. And we went ahead and found sine of 2 theta and cosine 2 theta. So what we're going to do here is say this is 2 times sine of 2 theta times cosine of 2 theta. Sine theta is 3 square root 7 over 8. So 3 square root 7 over 8. And cosine of 2 theta is negative 1/8. So negative 1/8. 2 times 3 square root 7 times negative 1 is negative 6 square root 7. And 8 times 8 is 64, which reduces to negative 3 square root 7 over 32. Yep, there you go. You can check it in the calculator, but the calculator can't give you some of these. So negative 1/8 it could, the radicals it couldn't. Backside, oops, not backside, second side. Verify. So we can now verify that things are identities because we've got a couple of extra formulas that we can use. So here we have sine plus cosine squared minus 1. First thing I'm going to do is do my sine plus cosine times sine plus cosine minus 1. All right, I'm going to basically FOIL here. Sine times sine is sine squared. Sine times cosine is sine cosine. Cosine times sine, I'm also going to write as sine cosine. Cosine times cosine is cosine squared minus 1. Now, sine squared plus cosine squared is equal to 1. So that's 1. These are like terms, so I can combine them into 2 times sine theta cosine theta. And then I've got this minus 1. Well, the 1 and the minus 1 add up to 0, and I get 2 times sine theta cosine theta. Well, that didn't give us the other side, but the formula for sine 2 theta is 2 sine theta cosine theta, so that means this does equal sine of 2 theta, and we have verified. This one, I'm going to go ahead and simplify this side. 1 over cosine plus sine over 1 over cosine. Well, actually, I'm sorry. Let's do it a slightly simpler way. I'm actually going to split this up. Secant A over secant A plus sine A over secant A. This will be 1. And then this is sine of A over, and I'm going to replace this with 1 over cosine of A. So that's 1 plus sine A cosine A. Remember, dividing by a fraction, same as multiplying by a reciprocal. Okay, well over here I got 1 plus 1/2 sine 2A. So let's go ahead and replace sine 2A with the formula. So that's 1 plus 1/2, and now my formula is 2 times sine A times cosine A. The 1/2 and the 2 cancel each other out. This is 1 plus sine A, sine A times cosine A, which is what I have, so we've verified that identity. One application problem. In this formula, R represents the horizontal distance that a fired rocket travels, theta is the angle at which it is fired, V sub 0 represents initial velocity, G is the gravitational constant, 9.8 meters per second squared. Simplify. Well, what they really mean here is they want you to notice that if you just change the order of the 2 and the V sub 0 here, you have exactly the formula for sine of 2 theta. So we're going to replace that. So this is now V sub 0 times sine 2 theta over, well, let's go ahead and replace g with 9.8. So that is a simpler looking formula than this is. V sub 0 times sine 2 theta over 9.8. The maximum range occurs when theta is 45 degrees. Find r if V sub 0 is 125 meters per second. So we're going to replace V sub 0. And this is sine of 2 times 45 over 9.8. Now, we use the identity when we know something about the original angle value and we need to know something about the sine of the double angle. In this case, when we actually know what the number is, we can go ahead and do the multiplication. So this is going to be 125 times sine of 90 degrees over 9.8. And 90 degrees is 1, sorry, sine of 90 degrees is 1. And you can go ahead and plug that in your calculator because I don't have my calculator handy. That's it. That's how you do it.